What announcement do I have to make today? Does anybody remember? Let's see our schedule. Okay, 6.3. Oh, so today this is section 3, and next week we're gonna work on section 4. Then you have quiz and chapter 6 review. Then you're gonna have chapter test. So possibly, it's tentatively, okay? Tentatively, April 7th will be the testing day, or it can be second. It depends on how we do on the section 4, okay? So either April 2nd or April 7th will be our test day. April 5th, we don't have a class because it's, I think, after Easter. We have a break. So either 2nd or 7th of April will be our test day. So the day before that, our meeting will be in the lab for our review. Okay? So I will talk about that again once we are almost done with the section 4. Okay? Just keep that in mind. Okay, so after we're gonna finish section 3 today. Okay. Did you guys solve this problem? Yeah, I see a lot of nodding. Awesome. So help me out, okay? Speaker mode. Okay, without your help, I cannot do anything. Okay, let me put this in. If you're still working on it, yeah, go ahead and finish that. How is this problem? Easy? So-so? Easy, so-so? Or no, it's hard? Hey, everybody, show me your thumb. Okay, I see a lot of mix of this and that. Okay, some of this. Okay, so let's solve this together then. Okay, so help me out. All right, so we have a question here. Let's read it carefully. We have 35 and a half yard of material available to make towels. So we have long material, 35 and a half yard. Okay, each towel requires 3/8 yard of material. So suppose this is my material. It's not beautiful, but I suppose this is 35 and 1/2 yard. Yeah. Thank you. Okay, so this is 35 and a half yard long material. Okay, and each towel requires 3/8 yard. So let's suppose this is 3/8 yard, same unit. Luckily, we don't have to change the unit. Yeah, something's wrong with my mind. It's always slanting. It's not straight. Sorry about that. But you know what I mean here, right? So 3/8, and so on and on, right? So we need to find out how many of these towers will be in 35 and half yard. Does it make more sense if I draw the picture like that? I think it does, don't you think? Yeah, so a lot of times when you are drawing the picture or make a representation, it really helps students to think better, okay? Okay, so how can we find how many of these are here? What kind of equation can we set up? What kind of operation do we need to do? Division? Okay, so we have a total number of that, and you can divide 3/8 in each, right? Because this is same as a repeated subtraction. You are repeatedly subtract 3/8 from 35.5 yards, right? So we start from 35.5 and divide it by 3/8. Then it will tell you number of towers, right? Okay, so let's take a look at that. We have 35 and half divided by 3/8. How can we do the division of fraction? Oh, hold on. So divided by fraction, we can change that to multiplication of what? Multiplication of a third, reciprocal, right? A third. Multiplicative inverse is a third. So we can just change this part, right? Okay. Now, there are two ways, or we can think about different ways too. But to me, I can think about two ways. So one, you can change that to improper fraction. And you guys said you love to do that. Me and some of you, we like distributed property. Okay, so let's do both of them for now. Okay, if we change that to improper fraction, how can we change 35 and 1/2 to improper fraction? In 35, how many halves are there? In 35, how many halves are there? 70 or 70. Because double of 35 is 70, right? So if you're thinking about these whole, and let's suppose you have 35 of them, how many halves are there? In one, you have 2 1/2s, right? So in 35, you will have double of 35 1/2s, right? Okay. So you have 70 1/2s in 35, but you still have one more to that. So you are adding that to it. If we're using the formula, you can just do multiplication of these two, 35 times 2, and add 1 to it. That's exactly the same as this, right? So you have that times 1/3. And 70 plus 1 is 71 over 2 times 1/3. Can we simplify this? Yes, we can. I prefer to simplify from here rather than multiply them out and think about what can be, divisible by both. This is so much easier because you already have factors there. So for example, I see, 2 goes in 4, and 8 by 4. So divide both by 2, right? How about here, 71 and 3? Nothing, right? 71 is, what is 71? What kind of number is that? When you have only one in itself as a factor. Prime number. So 71 is a prime number, so it doesn't have any factor that shares with 3. So now we are done. We can just multiply out 71 by 4, and 1 by 3. What do we get? 71 times 4. 284. 1 times 3. 3. How can we change this to mixed number? We can divide this by 3, right? So let's do that mentally. 3 times 1 makes 280. Close enough. 9? Because 3 times 90 will be 270, right? And if you subtract 270, what do we get? 14. Are you following me? Okay, so we are having 14 there. So 3 times what is close to 14? 4, which is 12. So 14 minus 12 is 2. So 2 is left. What's our denominator? 3. We still have 3 there. 3. 94 and 2/3. But our question, let's look at the question again. Our question is asking how many towers can be made? Are we making 94 and 2/3 many towers? No, we are not, right? So because you're not gonna sell, 2/3 of a towel, right? You're not gonna sell 2/3 of the towel only this size. You need to have a whole towel, right? So we are looking at only the whole numbers. Yeah, 94. So from here we can say 94 towels. In this case, we just disregard the remainder. Okay? Okay, any question for this? All right. Does it make more sense now after we solve it together? Awesome. Okay, so let's look at the next problem. I'm gonna erase this, okay? All right. Next one is saying, how much material will remain? Ooh, well, how much was it remaining? 2/3 of the yard, right? 2/3 yard of material. That was the leftover. Okay, so we are good. All right. Okay, please jump in if you have any question, okay? How about here? A bookstore has a shelf that is 37.5 inch long. Each book that is to be placed on the shelf is 1 1/4 inch thick. So we have both same unit. The unit is very important, right? Okay. How many books can be placed on the shelf? If I draw the picture with this one to represent the situation, we can do the same thing here, right? So a bookstore has a shelf. Okay, I have a shelf here. Three-dimensional. This is a bookshelf, and this is 37.5 inch long. Each book that is to be placed on the shelf is 1 1/4 inch equally. So the book that I'm gonna put up here, each book has the same thickness. Not bad, right? Let's suppose they are equal width. So that is from here to there. That much is 1 1/4. Same here, 1 1/4. 1 1/4, 1 1/4. So we got the idea. It's very similar to the tower problem, isn't it? Yeah? Okay, so we need to figure out how many books can be placed on the shelf. So how can we solve this? Tell me.
37.5 divided by 1.
You guys agree?
Yes.
Yes, me too. Okay, so to solve this one, how can we solve it?
Take the next numbers and proper fractions.
Yeah, that's one way. Or we can use distributive property too, because we're gonna Morgan. I'm sorry, not Morgan. Hey, Madison. She's so stubborn. But I'm stubborn too, so I'm gonna go both ways. Okay. Win-win. Okay, so we're gonna do both ways. One with the improper fraction, two with distributive property. How about that? Okay, so let's work on this. Improper fraction. You're gonna change both of the numbers into improper fraction? Okay, awesome. Okay, so help me out. What's 37.5? 75 plus 1? I'm sorry, 74 plus 1. Okay, so it is 75. Thank you. Divided by how many 4s? 4 times 1 plus 1? 5. So we can change that to 4/5. Okay. Anything can be cancelled?
Yeah.
Okay, which ones? 2 and 4. 5 and 75. How many 5s go into 75?
15.
15. Thank you. So we have 15 times 2, 30. 1 times 1?
1.
Oh, so exactly 30 many what? Books. Thank you. And another way is distributive property. Because you are going to be the teachers, you need to know both ways. about, you guys think about how you can use the distributive property. Because you all know how to use the improper fraction now. And I'm going to give you some time to think about using the distributive property, okay? Divided by, we can change that to improper, so we have 5/4. I will do a little bit of steps here, but you're going to do the rest of it. We have 37 and 1/2, right? 37 and 1/2, I just separate that with addition. Divided by 5/5, we can rewrite that as multiplication of 4/5. Now we can distribute each, right? So you're gonna distribute 4/5 to 37, and you're gonna distribute the same number to 1/2. Okay, and to the following. Bless you. You got it? Okay, so what's 37 times 4/5? It's still fifths. 37 times 4 is, what is it? 37 times 4. 4 times 7, 28. 30 times 4, 120. So 128. Yeah. And we have 1/2 times 4th. I can simplify this. So I have 2/5. We have the same number? Yeah. Okay. And then you have how many fifths? 130. Are we good? Okay, 130 is divisible by 5 because it's 0. It ends with a 0. It is divisible. So what do we get? Did something go wrong?
It should be 148, not 128.
Oh, this one. Thank you. So it is 150. Thank you. Okay, arithmetic error. Thank you for fixing it. Oh yeah, 21, no, 28 and 120, so it is 148. Thank you. So now, 150 divided by 5 is 30. So whichever method you're using, you are supposed to get the same answer. So what's the benefit of knowing, both ways? You can check easily. If you are using only one way, you're gonna make the same error. You tend to make same error. But if you are using different method, you can check your answer with more accuracy there, right? So think about that. All right. Any comment or question? Are we good? All right. So go back here. Okay. So let's think about mental math and estimation with rational number. So once we come to mental math and estimation, we're almost done with this section, right? So you have some sense of that. Okay, so let's put our pencils down and use our brain. Okay, use rational number properties to compute the following products mentally. What is your idea to find the answer mentally? Well, if we're not doing mentally, we know that we need to do the parentheses first. PEMDAS, remember the order of operation, we need to start from parentheses. Since this is multiplication here, and the multiplication is hidden here too. So it's actually multiplication and multiplication, so we know that we can use the commutative property, right? Or we can also do associative property, right? So think about that. There should be some properties that you can use. So do you think it's easier to solve this first and then divide it by 4 or multiply these product by 1/4? Or you're going to move them around somehow or associate them differently? What would be the good way to solve this mentally? Tell me any idea you have. Jump in.
1/4 of 12 would be easy to start.
I think so too, because 12 is divisible by 4, right? 25 is not divisible by 4. So I'm going to move these two around using the commutable property of multiplication. So I can have 25 times 12 times 1/4 and get rid of that, parentheses and put that between 12 and 1/4. So we are using both commutable property, right? Moving them around and associating 12 with 1/4 instead of 25 and 1/4, okay? So we are multiplying 12 times 1/4, which is 3. What's 3 times 25 then? 75. So we can easily find it, right? How about this one? How can we compute the product mentally? People on the Zoom meeting, you can jump into. Anybody?
I would take 5 times 6, which is 30 plus 1 over 6.
Can you say that out loud?
5 times 6, so that it's an improper fraction, I would take 5 times 6 plus 1. And then if that makes it easier to solve for the 12.
So you're gonna change this to improper fraction. So 5 times 6 is 30, 31 over 6 times.
And then the 12 and the 6 is cancel out.
Okay, so cancel out and you get
31 over 1 times 2 over 1, I think.
So answer should be
31 over 2, 31 over 1. I don't know.
yeah, it's confusing, right? So that is not really easy, but I followed you. So I can do that. So follow up, okay? 5 times 6 is 30, plus 1, 31, 31 over 6. And we know we have 31 in the numerator and 6 in the denominator. Keep that in your mind. And we have 12 there, so 6 and 12 can be cancelled with 1 and 2. So there's no more denominator. But we still have 31 up there, and we have 2 on 12 now. So 31 times 2 should be 62. So the answer should be 62. That's one way. Good job. Thank you. Or you can think of a different way too. Any other idea? Let's think about this as, no, 160 is not money. How about 5 and 1/6 of a pizza? And you are having 12 of them. And how many pizzas will be there? You're gonna count how many whole pizzas there, right? So you can separate 5 and 1/6. 5 and 1/6, separate them. And then you can distribute 12 to 5 and 12 to 1/6. How about that? That could be a little bit easier too, because 5 times 12 will be what? What's 5 times 12? 60. 60 whole. And what's 1/6 of 12? 2. 60 and 2, 62. So you can mentally easily solve that problem too. So in this case, what property did I use? I distributed 12 to 5 and 12 to 1/6. So that was distributive property, right? Okay, how about this one? What's your way, what's your method to find the answer for this mentally?
Find 1/5 of 20 and then take that times 4.
I don't know who's speaking. Okay, thank you. Okay, can you say that again? Sorry.
I would take 1/5 of 20
1/5 of 20,
and then take that times 4.
4. So you have 1/5 of 20, which is 4. 4 times 4, 16. You can do that easily, right? What property did we use? We use the commutative property here because 4/5 same as 4 times 1/5, right? And you did 1/5 times 20. Oh, actually, it's an associative property. So I will show you what we did here. Okay, so here, 4/5 times 20. 4/5 means it's 4 times 1/5. Do you agree? And then you multiply that by 20. So 4/5, we actually have 4/5 like that without having that parenthesis in the middle. It's 4 times. Four times. 4/5 means 4 times 1/5, or 4 over 1 times 1/5, right? Okay, so we have 4/5 as 1, and you multiply that by 20. But instead of doing this, we did 4 times 1/5 times 20, right? So it is the associative property of multiplication. Make sense? Okay, and we cancel these out. And what? 4 times 4. This is 60. Are we good? All right. Okay. How about this one? Can you estimate this time? Estimate each of the following. So we are doing estimation too when we are not able to use our pencil or paper or calculator, right? So let's think about how we can estimate the number here. 3 and 1/4 times 7 and 8, 9. How to solve this? It doesn't have to be accurate, but we can just estimate it, right? Close enough to the actual answer. How to solve this?
Change 7 and 8 ninths to 8.
This is very close to 8. I agree. How about this one?
Pretty close to 3.
Pretty close to 3, right? So 3 times 8, which is 24. We can say approximately 24, right? We know the answer should be between 3 times 7 and 4 times 8, right? And our approximation was in between those two numbers, so that should be good. How about this one? How would you estimate this? You can either change this to 25 or 24, right? It's slightly more than half of, we say 24 and a half, right? So we can go with 24, and we can lower down this to 4, but we can also do this as 24 because 25 is not an easy number to divide that by 4. It's okay. So we say that it's about 24 divided 4. That's also okay. All right. Okay, so we got that estimation, and let's think about the notation of exponents. We already know the meaning of exponents, right? For instance, a to the nth power means we are multiplying a how many times? M many times, right? So there are m many a's in this. We can do this to the rational number too. When a is the rational number, we can do that, just like what we did with integers or whole numbers or natural numbers. Okay, so we know this is m power. Some of the powers they have a specific name. For example, if m is 2, what do we call that? A squared, right? If m is 3, we call that a cubed. After that, we can just say a to the 4th power, a to the 6th power, a to the 7th power, a to the nth power. Okay? So for example, a cubed times a square means a cubed means a times a times a. A square means you multiply a twice, right? So a times a. So what is the multiplication of this? Okay, what is hidden in between these two numbers? Multiplication again. So you can actually just combine them together. We are counting how many there are. So there are total 3 and 2, so 5 many a's there. So what do you notice from here? when you have a to the m's power times a to the n's power, you can just add those exponents. Make sense? Okay. So we can have a rule. A to the n's power times a to the n's power will be a to the n plus n's power. Okay? Then let's think about the same thing. A to the negative third power times a to the third power will be, we're going to just add those exponents too, right? So when you're adding negative 3 by 3, what do you get? 0. So a to the 0 will be 1. How can we prove that? We can think about this one too. A to the negative third times a to the third is a to the 0 power. We know that by adding these two together, it will be a to the 0 power, that is 1. And here's one thing that we need to know too. A to the negative power doesn't mean that a is negative number. Okay? Then negative power means it's reciprocal. So for example, if a is, let's say, 2/5, a to the negative power means reciprocal of that, 5/2. Okay? So if you are having a times a negative 1 power, so a to the 1 power times a to the negative 1 power, we know that it's going to be a to the 0 power, which is 1. So let's take a look at this specific example, okay, and apply that to this rule. A to the 1 power, we know a is 2/5. This is this example, okay, 2/5. And a to the negative 1 power is the reciprocal of that, which is 5/2. And what happens? 2 and 2 will be cancelled, 5 and 5 will be cancelled, so we get 1/1, which is 1. Okay? So when you have same power with different sign, multiply them together, you get a to the 0 or just 1. Okay? Because that's the reciprocal of each other. So remember that a to the negative m's power is just reciprocal of, the negative means reciprocal of a to the m's power. Okay, that doesn't make a to the negative number. Okay, just keep that in mind. Any question? Okay. Okay. So we have that idea, a to the negative n's power means, the negative power means it's reciprocal 1/. Okay, 1/. So let's take a look at these. I want you to think about a pattern here. Okay, so we know 10 cubed means 10 times 10 times 10, 10 squared means 10 times 10, 10 to the 1's power means 10, 10 to the 0 power is 1. What could be 10 to the negative 1 power? So from here to there, what did I do? By just reducing 1 power there, I divide this by 10, right? So 1/10 is gone. From here to there, I reduced the exponents by 1. But here, how did I move 10 times 10 to the 10? By dividing this by 10, right? So the pattern here is I divide each number above by 10. Let me rewrite that. So we know 10 cubed is 10 times 10 times 10. 10 squared will be 10 times 10. And you can see the pattern here. From here to there, I divided this by 1/10, right? So this and that will be cancelled. And I'm reducing 1 more power there. This is 10, we know that. The pattern here, hey, I just get rid of 10 by multiplying that by 1/10. Keep going. 10 to the 0 power is 1 because I divide this by 10. Then what could be next? I am reducing the power by 1. 0 minus 1 should be negative 1, right? That should be what? I divide this by 10, which means 1 times 1/10. will be 1/10. So that's another way to show 10 to the negative 1 power is 1/10. Okay? Okay, subtract one more from negative 1 and we get negative 2. And you're gonna multiply this by 1/10 again, right? So we have 1/10 times 1/10. Do you see the pattern? You can go backwards too, right? And the negative third power is 1/10 times 1/10 times 1/10. Or 1/10 to the third power. So these are exactly the same thing. Make sense? Awesome. Okay, so knowing that, we can solve so many problems like this. 2 to the fourth times 2 to the negative third power. Let's solve that together. And we have 2 to the fourth times 2 to the negative third power. We have the same base, right? 2 and 2. So we know that our base will be 2. Since it's multiplication, we know that we're gonna use this addition of the exponents, right? Plus negative 3. So it's 2 to the what power? 4 minus 3? 1. This is just 2. So that's one way. Okay, if you know the rule, you can just add them together because it's multiplication with the same base, right? Or you can just, extend it. 2 to the fourth is 2 times 2 times 2 times 2. Or multiplication, 2 to the fourth. And I know 2 to the negative third power means it's 1 over 2 to the cube, right? So I can just rewrite that as 2 times 2 times 2 times 2. And 1 over 2 cube means 2 times 2 times 2. So this 2 and that 2, this 2 and that 2, this 2 and that 2 will be cancelled. And I have 2 times 1 only in the numerator, and there's just 1 in the denominator. That's 2. Okay? So that makes sense too. When you're teaching this, you need to be, you need to pay attention to students' error. Sometimes they are saying, oh, there's nothing left in the denominator. What do you mean nothing in the denominator? Is it 0 then? Not really, right? There's 1 left, right? Make sure the denominator is not nothing, there's 1. Okay? So 2 over 1 is 2. What do you think about this? Not bad, right? Okay, good. All right. So let's give you one more example. How about you guys all solve this one? 2 to the negative fourth times 2 to the negative third power. Just tell me, what did you get? Anna?
It's gonna be 2 to the negative 7th power.
2 to the negative 7th power. How did you find it?
I added the exponents together.
There we go. It is multiplication with the same base, right? So you can just add those exponents, which is negative 7. So you can write that as 2 to the negative 7. Or if you are writing this as fraction, what can we write that as? 2 to the negative 7 is the same as what? 1 over 2 to the positive 7 power, right? Very good. Okay, so let me just rewrite that, the thing that we just talked about. Okay, so Anna used 2 to the 4th times 2 to the negative third by using addition here, because it's a multiplication with the same base. If she's got 2 to the negative 7, we know this is the same as 1 over 2 to the 7. We can do that. If the question is asking you to have not to have any negative exponent, you can have this, right? Same thing. Or you can just change this to 1 over 2 to the 4th times 1 over 2 to the 3rd. It's still the same thing. We have 1 times 1, 1. 2 to the 4th times 2 to the third, and you get 2 to the seventh power. Okay? Okay, awesome. You guys are pretty good. Okay, here's a few more theorems. I have so many theorems here, so let's go with the first one. We already know this one, right? For any non-zero rational number a and integer m, we know if the bases are the same. Echo. If the bases are the same and it's a multiplication, you can just add the exponents, right? Okay. Second theorem I'm adding here is with the same base. If it's a division, you can subtract the denominator exponents. So I will explain that to you. So when you're looking at this, a to the nth power over a to the nth power, we know it's going to be a to the nth times 1 over a to the nth power. This is in the denominator, a to the nth is denominator. So it is 1 over a to the nth power, right? How do we rewrite this? A to the negative nth power, because it's reciprocal of a to the nth power, right? So 1 over a to the nth is a to the negative nth power. Now we have same base, so we can just add them together. M plus negative nth power, or that's same as a to the m minus n. Okay? So the denominator part here, the exponent is subtraction. For example, if you are given 2 to the third over 2 to the seventh. This is the same as 2 to the 3 minus 7, which is 2 to the negative 4. Or it's 1 over, using that negative as 1 over, it's reciprocal, 2 to the 4th. Right? Or you can think about it this way. Writing the same thing that is equal to, not arrow, this or that. Okay? So 2 to the third is what? 2 times 2 times 2. 2 to the seventh is 2 times 2 times 2 times 2, 7 of them. So we know all of these 3 will be cancelled and all of these 3 will be cancelled. How many is left? How many is left? So we know it's going to be subtraction there. So 4 is left. Which is same as 2 to the negative 4. So this is kind of tedious if you keep doing that, but at the beginning of teaching it, it's always encouraged for you to, extend it and show the cancellation there. So how many is left? Which means we use the subtraction there. So we can just use the subtraction here, okay? These are exactly the same thing. Any question? Okay. So I'm gonna add a little bit more. Okay, how about this one? Now we have a to the nth power holding to the nth power. So you might have heard power over power, right? So you have nth power over nth power. So power over power, you want to multiply them together. Okay, so I will show you some example here. So for instance, if we are given 2 to the 5th to the 3rd power. What does 2 to the 5th power mean? It's 2 times 2 times 2 times 2 times 2, right? To the 3rd power. So you have this whole thing 3 more times. 3 more times there. So I know I have 2 to the 5th power in each parenthesis. Right? So now everything is multiplication. So how many 2's are there? I have 5, 5, and 5. So I have 5 times 3 many there, right? I have 5 times times 3 many 2's in there. So I just said 5 2's in 3 groups. This is same as 5 times 3 many. Okay? So it becomes 15. That's why we are doing power over power as a multiplication. Okay? So if we have a to the m to the n's power, power over power, you are going to what? Multiply them together. Okay? Versus a to the m times a to the n. What do we do? You're going to add them together. Okay? If you get confused, just extend a couple questions. Like, you make up a question just with the easy ones. What is this? Versus a to the second to the a to the third. Make easy questions like that. Erase these. Okay, so make up your own example and think about, what you need to apply that to. So for example, if you are making up these two questions, you can say that, oh, a to the second is a to the second to the third means I'm multiplying a to the second 3 times. Right? And I have AA. So total, I have 6 of them there. So this one, I know it's going to be a times a times a times a times a. The total, there are 5 of them. So you can compare them too, okay? So if you don't remember, a to the m to the n is the power over power, so you're multiplying them. And a to the n's times a to the n's is just addition of that. If you can memorize it, you can memorize it too. But if you don't, if you cannot memorize that easily, you can always think about one example, okay? Make up your own example. All right. So here's, I think one more, and 2 more. Okay, so this theorem, for any non-zero rational number a over b and any integer m, so it's saying any integer as the exponent, right? Because we are taking positive, 0, and negative number there too. Okay? So a over b to the negative nth power, if n is a positive number, what happens? We just do reciprocal, right, of the positive integer. Do you need any example for that? We already have shown so many, right? So we don't have to. Just remember, negative power means it's reciprocal. So you are flipping a over b as b over b a and changing the sign. Okay. All right, last one here. For any non-zero rational numbers a and b and any integer m, a times b whole thing over m's power, what do we do? You're gonna distribute that power to each of the bases. Okay? So what that means here is this. So if you are given limited time, let's go like this: 2 to the third to the fourth power. For example, if this is given, you can just do, well, we usually do the exponent, in the parentheses first, 6 over 4, right? So what is 6 over 4? Does anybody have answer? That should be same as 2 to the 4th times 3 to the 4th. How about you guys compare these two answers and come to the class next time? Or, no, not really. Let's just do that now. What's 6 to the 4th? Come on, guys, let me finish this. 6 to the,
It is 1,296.
How about 2 to the 4th? 16? 3 to the 4th? 81? multiplying them together, I get 1,000. Okay, okay, so then distribute their power to each of them. Quickly maybe look at what we have in the next slide. I think we are done. Here are some more properties. It's just summarizing it in the notes. Okay, so take a look at the notes, and this is just last example that we're gonna do. So I'm not gonna do this with you. It will be part of the homework. Okay, so you have to finish this one along with 6.3 homework that is due Monday. Good? Okay, sounds good. Okay, have a great weekend, guys.
Thank you.
It was so smart. I appreciate it, man.